Any latecomers will join us. Okay, I think that we can start now. So welcome everyone. Welcome to this session on with an interesting, very interesting topic for the success of the battery value chain, which is about ensuring safe and sustainable access to raw materials. So my name is Philippe Jacques. I'm the Managing Director of EMIRI, the Energy Material Industrial Research Initiative, and also acting as the Secretary General of BEPA, the Batteries European Partnership Association. So happy to see so many people in the room, and welcome also to all those who are following us online. So don't hesitate to, for those who are online already, to put your questions in the tool, in the online tool, during the presentations, and we will make sure to address them during the panel session. So we are going to have first a general introduction about what's the landscape and the big issues on for raw materials for batteries. That will be presented by Chris Aaron, who is the Director for Communication and Public Affairs at Eurometaux. And then we will, after this general presentation, we will directly jump into a panel discussion with some very knowledgeable people that I will be happy to introduce in the introduction part of the panel. So, well, I don't want to take more of the time of the session for just introducing it. So, Chris, the floor is yours.
Thanks. I'll wait for my slides to come up on the screen, but great to be here today to talk through Europe's raw materials challenge with you here at Battery Innovation Days. My name's Chris Aaron. As mentioned, I'm from Eurometaux, which is Europe's collective association for the metals industry, representing companies mining, refining, and recycling the full range of metals in Europe. For the next 15 minutes, I'll provide a snapshot of a groundbreaking study we released earlier this year with the Belgium University KU Leuven, which for the first time quantifies the metals requirements of Europe's clean energy goals and the supply routes, the supply challenges for getting there. It's a timely discussion today because the European Commission is working on new raw materials legislation, which it should announce at the start of next year. And actually, the President of the European Commission, Ursula von der Leyen, will be talking more about that in her State of the Union address tomorrow. So I'll also provide a few indications of where we as an industry would like to see this policy be directed. But to move quickly forward, and to frame this debate for the fellow panelists as well. To move quickly forward, the key task we have ahead of us is that our energy transition, as many in the room will know, requires a massive increase in its metals demand by 2050. The study we did with KU Leuven is looking at a range, I think about 20 different metals, which have a clear demand link with the energy transition. But within that, it focuses on three core groups: the base metals, the battery materials, and the rare earths, which will really be driving our electrification and decarbonisation forward. Of course, today I'll focus mainly on battery materials as we move through the discussion, but just some top-line data from the study before we dive in. For the base metals, aluminium, copper, and silicon, they're used around us widely in our applications today, in our cars, buildings, packaging, and electronics. They're also fundamental for electrifying the economy. They're all used in batteries in some form, silicon increasingly in the anode, and aluminium and copper in supporting functions. We estimate the energy transition will require 33% more aluminium, 35% more copper, and 50% more silicon by 2050 to meet applications from grid infrastructure to solar to EVs. The battery materials, it's a different story because, as we know, we're not using high volumes of battery materials in Europe today. So nickel, lithium, cobalt, also manganese and graphite, which are less in the focus of our analysis. Only nickel is used widely in stainless steel, but for the rest, it will be when Europe is establishing its gigafactories and its cathode production capacity that demand is really accelerating. The numbers in our study is that Europe will have to double its nickel consumption in the next 30 years. Cobalt consumption increased by 331% if we take our knowledge of today's technology development until 2030 as a barometer. Things can, of course, change. And for lithium, a massive 3,500% demand increase. For the rare earths, I won't go too much into detail there. They're used for permanent magnets, for our EVs, our wind turbines, similarly large numbers if the EU is successful in establishing a permanent magnet supply chain. And our raw material needs are very dependent on our success downstream in other applications. The question then is, how and where do we get all of these metals from in the next 3 decades? Here we see 2 key challenges, a challenge of availability and a challenge of sustainability. In terms of availability, how can we overcome the ever-growing demand and supply gap for the metals we need in the next 15 years in particular? In our study, we estimate that globally we'll require about 3 million tons of lithium by 2030, which is a steep increase on today's levels, I think about 6 or more times. If we're adding up, A, the total global supply that we have for producing lithium today, and B, all of the projects announced in the world for that material, then we still have a 37% shortfall for what we need in an aggressive decarbonization scenario globally. That lithium can only be provided through a rapid expansion of new mines and refining capacity, and we know that's a time-consuming process, 10 to 15 years on average to open a new mine from discovery. Similar bottlenecks also for copper, for nickel, as we move forwards. And the second challenge for Europe is certainly one of sustainability, also diversification. How can we avoid that our demand gap is filled only by single suppliers from potentially lower regulatory regimes? We're living through an age where our overdependency on fossil fuels from certain regions is really causing us problems as an economy. And there's a big concern that the current dependence on Russian gas, for example, could be replaced in particular by a dependence on Chinese processed metals as we move through the energy transition. China, as many of you will be aware, has been strategically looking at its metals industry for over 10 years. It's had an aggressive industrial and state subsidization strategy to establish a position of dominance on global markets. It's the world's largest producer of nickel, with 35% of global capacity, 40% for cobalt, 60% for aluminium, 65% for lithium and cobalt, and a massive 90% of rare earths. And even when China does not have the resources it needs domestically, it's very effective at subsidizing its companies to buy competitive assets abroad. It controls 15 out of 17 cobalt mines in the Democratic Republic of Congo, a majority of Indonesian nickel, and growing South American assets as well. So it's a real strategic question for Europe, and that's why the raw materials legislation we should see at the start of next year is so crucial to put us on a path that we develop a globally diversified supply, and we're not going to be falling into a trap of similar dependence as we move forwards. But to move to the solution, where I'll spend the rest of the presentation, which is also the supply routes Europe has to address this challenge, and then hopefully that sets up well the Q&A that follows. We have a starting point today where we want to have a more autonomous clean energy system, and we want to establish the right level of sustainability, and an endpoint in 2050 where our battery supply chain is fully integrated in this way. In our study, we identify 5 pillars for bridging this gap. 5 pillars which I'll touch upon one by one before reaching some conclusions. We split these 5 pillars into 2 groups. The first group has its strongest impacts between now and 2040. And that is the earlier stages of the energy transition, where the clear priority, particularly for batteries, is to bring on primary materials into our new technology supply chains at the lowest impact we can. And as Europe, we have to find the right balance between domestic and supply and imports for achieving these inputs. The first pillar that we have at our disposal is to fulfill our domestic mining potential, to open new mines in Europe. A clear message from our study is that there is potential to open new mines here this decade, but challenges must be overcome at the same time. Lithium in particular is a battery metal with the healthiest project pipeline domestically. There's a range of projects across a variety of member states of different sizes and profiles. If it's delivered, it could provide between 25 to 50% of what Europe is currently planning for its cathodes. That number could develop further if Europe expands its cathode capacity as well. But the key thing with this potential is it has a very high level of uncertainty. As many will be aware, most of these projects have some challenges. Often local opposition is making delays. Many will have heard of the situation in Serbia. Challenging economics, permitting delays, and sometimes even the use of untested technologies which need to be demonstrated at scale. So while Europe does have a healthy pipeline for lithium which it can bring on, it's really undecided how much of our supply this will be able to contribute as we move through to 2030 when the bottlenecks are highest. A very last quick second message for some of the other battery materials, notably nickel. We have a lot thinner project pipelines for some of these other materials. For cobalt, it's very difficult to mine domestically. We don't have a lack of resources. The global supply will be the reality, and anything we do here in Europe will be much thinner, and we'll also be competing with the depletion of our existing mining capacity. So difficult to make a sizable change in some of the areas. But there is potential, a takeaway, to open new mines, and it requires political will, faster permitting, and also to drive the high ESG standards which customers expect. The second pillar is then to maintain and increase domestic refining output. This is less dependent on the geological resources we have here in Europe and is utterly crucial to supplying battery technologies and their production. The key message we have is that Europe will need more refinery announcements in the next 5 years to keep pace with the energy transition. We have a growing pipeline just in the last 2 years, specifically for nickel and for lithium, and we have existing capacity also for cobalt. And we hope that those projects are added to as we move forwards. New refineries domestically allow an advantage for European downstream customers of a much better CO2 performance and avoiding the China route for accessing those processed materials, as I mentioned earlier. Example on the screen of nickel, there have been 3 nickel refineries in the last 2 years, I think, which add 24% onto Europe's capacity. So we are making progress. But the key question in terms of policy is, can Europe create the competitive and predictable regulatory conditions that businesses need to have their predictability? There's a few cases where we're concerned that's not happening currently. One key challenge is the chemicals legislation that the European Commission has. Most of these chemicals have hazardous properties of some form, and the regulatory procedure for regulating them is quite heavy. Most notably, at the moment, lithium is undergoing a process to potentially be identified as a toxic chemical, which creates a lot of unpredictability for companies making investment decisions into this supply chain. We don't know what the future is, what the requirements will be, and we know that companies are withholding their investments until we see this scene clear. So we really, hopefully, need to be looking at a more joined-up approach where we can provide companies the predictability they need in chemicals. And the second key challenge is the energy policy. Most of the refining that we have here in Europe is struggling a lot at the moment from the energy crisis. 50% of our aluminium and zinc production is currently offline, and we're concerned that that's a very difficult environment to make new investments in if this crisis prolongs for several years. So we need new capacity, but that definitely requires much stronger business conditions to be sure that it's going to carry forwards. The third pillar is then to secure sustainable imports from reliable partners. And however successful we are in pillars 1 or 2, the reality is, definitely for our battery supply chain, that Europe will rely on imports for its short to medium-term demand growth, either of the ore, if we establish our refineries, or the metal, if we're not able to capture that part of the supply chain. In the study, you can see there's a quite steep demand curve projected for most of the battery metals on the right of the screen up until 2040, even if, as mentioned, our domestic investment strategies are successful. And then again, 3 key challenges which we have to be tackled in any raw materials action. A challenge of availability. Will there be enough on global markets for Europe to secure what it requires? We've talked about the bottlenecks we can project around 2030. Actually, we're advocating that Europe could be bold and support some of its companies to access and invest in some of these competitive mining resources abroad. Secondly, sustainability. Do we want to swap our existing fossil fuel dependencies with imports with lower sustainability credentials? Here, the real focus needs to be on certified responsible partners, and there's a lot of work ongoing from our supply chain to demonstrate that best practice. And lastly, diversification. Can we maintain our high diversification as these requirements increase? Will there be single suppliers in the future that we have this overdependence on? Strategic partnerships that Europe is developing with like-minded countries, from Canada to Norway to Latin America, will be crucial to establishing those links. However we do things, the imports will be a key challenge, and we need a global strategy for dealing with it. That brings us to 2035, and then the good news that the pillars 4 and 5 come into play a lot more significantly. The mid to later stages of the energy transition mean that metals from first-generation products are starting to enter the recycling loops in higher volumes, providing a permanent supply source to Europe's industries. And pillar 4, maximize recycling, including new streams, will be a key priority to start action on now to reap those rewards in 1 to 2 decades' time. A message from the study is that recycling is Europe's key long-term driver in creating strategic autonomy for its battery materials and other strategic materials. After 2040, we see a massive potential from end-of-life volumes that will be available from the urban mine. Currently, the end-of-life recycling rates for pure battery metals are very low, between 0 and 8%. Nickel is recycled in the stainless steel recycling stream, which isn't captured here. There's also the scrap that's recycled from battery production processes, which we're also not capturing. But the key message is, if we look at the end-of-life recycling flows, there's a massive shift that will happen by 2040 and then 2050. In 2050, the study forecasts that recycling volumes in Europe could provide between 65 to 75% of Europe's needs for battery cathodes, depending on how they developed. But crucially, this doesn't happen automatically. There's a lot of work we need to do now to prepare for those flows coming in. Investments into new recycling capacity to keep up with the pace of these batteries coming available, which is already happening. Process improvements to become more efficient at recovering many of the metals in the highest efficiencies we can, such as lithium, for example. And lastly, which isn't mentioned on the slide, but we have to keep the scrap we generate We have to keep the scrap we generate in Europe to be recycled. There's also a big risk that the scrap we generate will just be shipped elsewhere. For example, the black mass that comes as an intermediary in the process, we already see there's high demand for it in South Korea or in China to establish their own supply chain. This isn't a given, and it's an area we can make measurable progress on now to create the regulatory framework for keeping those resources local. The last pillar, pillar 5, is to drive technological and behavioral change. This is assessed in much less detail in our study, but it can be a crucial long-term lever. One striking conclusion from our analysis is that of all the metals and all the applications needed in the energy transition, about 60% is just located in the transport sector. There are 2 levers which are being pursued to try and adjust the number of metals that will need to go in that sector as we move forwards. Firstly, innovation and substitution. Europe's already a front-runner in its R&D for reducing metals intensities, and we can see the substitution focus to use less cobalt in our batteries, commercialize new non-rare earth magnets. That will surely increase from 2030 onwards, beyond the timescale that we've been able to predict. New battery chemistries, etc., could really change the picture. And lastly, wider behavioral change, also impossible to predict, but there are growing calls for Europe to change the structure of its mobility system, use less cars on the road. This will, of course, have an impact on our demand for metals. Impacts, though, will be longer term. So key takeaway, further efforts, yes, they can be made here, but for sure they will probably be longer term in duration. And that takes us to a conclusion for the presentation. Europe's raw materials success is dependent on building these 5 irreplaceable and essential pillars of the bridge together. If we do that, we can avoid challenges of availability, sustainability, particularly in 2030, 2035, when those challenges are highest. As a last note, though, it's sometimes difficult to know where to start building with a bridge of this size. And when we look at the raw materials legislation, we give the message that this bridge that we want to build, it needs a strong foundation to be sustainable and lasting. There are three key elements, particularly looking at domestic supply, which can be improved to get things forward: permits, finance, and frameworks. So in terms of permits, we can get it much quicker to bring projects online, taking timelines down from 10 years to 3 times faster if we can improve efficiencies at national level. Finance, making funding available from EU and national sources to de-risk projects across the value chain. And frameworks, giving these companies and operations the conditions they need to compete on fierce global markets: affordable electricity, trade defense where it's needed, and joined up environmental and chemicals legislation. Thank you.
Thank you very much, Chris, and I thank you very much for this very clear presentation. And I'm even wondering whether we need the panel discussion, because I think everything has been addressed already. But okay, please take a seat, and I will invite also the other speakers to join, the other panelists to join, and also to take a seat. So I invite Justo Garcia from Orano, who is the head of financing strategy in Orano, to join. Also Professor Marcelo Coledani of Politecnico di Milano, and Hachi Yagi, which is an associate scientist at Umicore, to come on stage. Thank you very much. Okay, so I don't know if you can come back to the slide with the different the different members of the panel. So to start with, I really would like to first to give you the floor for a first reaction on what has been shared by Chris, and really highlighting what you feel are the most important challenges that really need to be addressed from what was already well explained by Chris. Don't know who wants to start. Up to you. Justo? Yeah.
Okay. It was a very clear presentation, and so as a newcomer, as recycler, I see it's good news for my company because we see clearly that we have an important task in order to the recycling will be a mean to assess the material and to keep the material inside in Europe in order to avoid that typically Asian recycler brings this material, and so this is important and will be a key access to have a sustainable activity for all the value chain of the battery in Europe.
Marcelo. Nice.
Yeah, very interesting presentation. Thanks a lot. I would like to stress one point that you mentioned, the partnerships. I think it was your third pillar. It's very important to create stable partnerships on the medium-long term to ensure stable, in terms of quality and quantity, supply of materials. One comment is, you didn't raise this point. I think it was kind of subtly mentioned in your last point, the efficiency in which we transform, or we will transform, the input materials into output usable batteries. So the quality and the efficiency of the battery process chains that are under development. I think this is an important point because this amount of scrap that we read is predicted in the first, let's say, ramp-up phase of these plants is not yet there. So we can still proactively act on trying to shorten this ramp-up and improving the quality of the battery production system by advanced zero-defect manufacturing approach, and maybe by involving more and more the manufacturing community into this new challenge of safely and efficiently producing batteries. So I think this could be also a point of improvement that can somehow make the overall value chain more efficient in the short term, especially.
Thank you. It was also quite interesting, also very good news for Umicore as a battery recycler as well. But I think I'd like to address one thing. Well, there's so much activities on battery recycling. I think it's beautiful. It was so nice to see that so much involvement in this market. But at the same time, we have to think of what's the battery recycling. I mean, like we have to fully close the loop of the battery supply chain. And sometimes we see so many news about, let's say, battery shredding or battery dismantling and making black mass. But let's say the black mass can be still shipped outside of Europe, then we have to make sure if it's going to be shipped outside of Europe, it should be recycled and recycled back to Europe. And ideally, we need a good capacity of refining in Europe so that we can fully close the loop inside of Europe. That's something I want to address.
Of course, I'm going to ask you to speak again the conclusion of the KUL report, but I'm really challenging a little. Well, not challenging. Honestly, I don't know. But what is really the reliability of the figure that you were showing? Do you have any idea of really what is the worst case and the less impactful, the less impacting scenario that we have to anticipate?
Yeah, I think it was a robust methodology we used in the study. We looked at what we could see about developments in the future. Really, we only have a time horizon for what happens between now and 2030. So for the numbers we presented, that takes on an evolution that you can expect by 2030. So a reduction of cobalt content in batteries, increased penetration of lithium iron phosphate, and some other things. After 2030, it becomes a bit more of a crystal ball. So this is an analysis which would need to be updated in 5 years' time to have a better indication of what happens by 2035 and then to go forwards. So we're very conscious a lot can happen in terms of reducing intensities and other things, but impossible to tell all of the future now. And maybe reacting just to another point, for example, the improvements to efficiencies of the production process can be a very good thing to lower the material demand, but you also then have less scrap coming potentially from the production process from the recyclers. So it's a very complex mix that is coming through. I think it's a robust analysis to start the debate with.
Okay. Yeah. Coming to the question of the how to have more domestic activities. What are really so you were pointing some really key challenges about the necessity to accelerate permitting, but I think also, and this was mentioned already this morning, about changing the mindset of people so that really the citizens are not opposing against the coming back in Europe with this kind of mining and processing activities. How can we really change this? What are the levers that we have to really to make this again, let's say, accepted by the citizens in the different regions?
I think permitting is the easier challenge, hopefully, to tackle. There's a lot of inefficiencies in the system, which could potentially be improved if we agree these projects are strategic and give member states the clear signal to fast track them in their processes, allow them certain ways to not do steps one by one, but do them at the same time, different processes, rather than having to do a report, wait for the results, do another report, wait for the results. So we think there are some bureaucratic ways that the permitting process can be improved while still keeping the environmental rigor and the involvement of communities in the process, which is key because the bigger challenge is potentially the social license to operate, as you mentioned, for certain mines in certain communities. And that's a very difficult nut to crack, especially from the European level, where we already struggle with linking and resonating with local communities at that level. So I don't really have the golden answer apart from that the companies have to be transparent and involve communities to the best extent they can through the process. And authorities have to also facilitate that, but then eventually take the decisions needed if projects are strategic to go forwards. But that's potentially is the biggest hurdle we have.
I don't know if our industry panelists want to react also on this. Do you experience this kind of really of social opposition against recycling projects?
Well, like Umicore is no mining company, so we don't really invest in the mining itself. But let's say there's so much people thinking like not in my backyard, my mentality. So, well, on the other hand, we are asking like African countries or like other countries to refine our cobalt, nickel, lithium, which we don't really know. I mean, like we should put best effort to see what's happening there. But it's much easier to control in Europe. So we should be more aware on visibility in Europe. If we have mining in Europe, of course, it can secure our resources. Also, it increases visibility on what's happening there. So I think those kind of awareness, we should increase that.
Okay. For us, so we start the investigation for the implementation of new plants, and at this stage we have there are a lot of acceptance for new activity in relation with energy transition, and also a strong support of the region because it will be the opportunity to have new activity in some area.
Okay, so yeah, Marcelo.
Yeah, I'm not from an industry, but I can just comment one aspect. So that goes back to the previous comment. I think that the role of local communities is very important here, and the regions are playing an important role. The lever is also to show what you showed very well. So how all these actions are interrelated. So you cannot really isolate one action from another. So if you don't do an action, you will have a sort of amplifying effect on all the other possible actions that you are planning. So clearly, finding a way to transfer this concept to the citizens and to community is the trick to having an increase in acceptability as well, I think.
I would like to move now to the figures you explained regarding the transfer of all the refining activities outside of Europe. Most of it now is done, especially this is especially true for critical for the rare earths, but I think that's true also for lithium and others, like you showed. That most of this is done in China. What do we have to learn from the past? What was the driving force for that? It was really just because we were looking for lower cost and really reducing the impact on our environment here, that we prefer to have this transferred in this region. So that was you see also some other fundamental causes for this. So what is your feeling and your reading on that, and how to avoid and to come back to something that would be more secure and providing more guarantee of a partial autonomy to Europe?
Perfect storm, as you say. Europe at a certain point made a decision to let go of some of its more polluting industries, and often it was China who picked it up. And then more recently, China has really put its strategic metals and battery materials supply at the center of its industrial policies. And industrial policy means something different in China than it does here as well. Companies receive massive amounts of subsidies to get a competitive advantage in what they were building up and build to scale quickly, and advantages then on the global market to access companies, for example, in the Congo. That's how China occupied so many of the mines there too. So that's the reality is Europe's really playing catch up in this race as a consequence. And it's why we question so much some of the decisions I spoke about. For example, if it's such a challenge to bring lithium refining capacity here in Europe, we should be helping our companies and not making it harder to do so. Concerns, for example, with classifying lithium as a toxic substance without the scientific basis, we believe, and then adding a whole new load of regulatory requirements onto producers here, which aren't met in competing regions. Those sort of responses are making it harder for companies to grow and thrive in a race they're already behind in. So hopefully, with this raw materials legislation, we can be more coherent and we can really give companies the platform they need in terms of accessing finance, getting projects online quickly, and then having a smooth regulatory regime which is proud of Europe's strong environmental standards, because we do have high environmental standards, but is also not overburdening our companies versus the other regions too.
Can you tell us a little bit more on what will be tackled in this Raw Material Act, which is currently under preparation?
What we know is very under secrecy because, as mentioned, tomorrow it gets announced in more detail. But I believe the European Commission will like to codify which materials are strategic to the twin transitions. For sure, the battery materials should be included there. And then identify a list of strategic projects in Europe which contributes towards stronger self-sufficiency. And in doing that, they also have access to better permitting and the full financing possibilities of EU and national funds, a more active European Investment Bank, and more. Linked to that, there'll be some circular economy policies still to be defined, and the global partnerships angle, a clear strategy to form meaningful partnerships with other regions. What else we have to see, and I think a lot of interest in influencing it to be as strong as possible in this direction.
Do you have so you mentioned the upcoming speech by Ursula von der Leyen. Do you have a better understanding of what will be the next the agenda, when really this one will be fully released and so on?
That's the crucial question, is timing. Again, I believe they're debating it right now even, is what timing this legislation should have. There are parts of the European Commission that would like to rush it out as soon as possible to reflect the urgency of the challenge, and others that say, no, wait, we have to do the proper impact assessment, we have to do a lot of work before we come out with legislation. We'd hope to see some new legislation at the start of next year, but it could be delayed further.
Okay, if I move now to really how research and innovation can really support and help this big challenge about securing material supply. What would you see, again, are the main priorities? What are the main topics that you feel we should be addressed first, really, to contribute? And also, maybe more for you, how do you see innovation really being part of the solution? Well, I don't ask you to tell me exactly if you consider it's 20% or 50% of the solution, but how research and innovation is really part of the solution to this equation.
It's a massive part of the solution, and hopefully will find answers to questions in the decades ahead that this study has been unable to even see in its analysis through innovating towards new technology configurations, better efficiencies, recycling processes which can recover maximum number of materials, and also even in the mining stage, innovating to be more efficient in how we mine, decarbonize processes. I think the whole supply chain has to come on and solve some major challenges, not just technology-wise, but also in terms of sustainability performance, where innovation has to play a role. And I'm here in Brussels dealing with the policies, and so the innovation world's often a bit foreign to what we do. So I'm happy to hear from the experts here and how that contributes further.
Okay, so now I come back to my question to the other panelists. What are in your opinion, the priorities really to address from an innovation point of view?
Yeah, effectively, Orano is convinced that the technology will be very important to develop new activities. And for us, when we said new technology, is in order to enhance the recovery of the material, because it will be important that the technology recovers the maximum of material, because as we saw, it's very important for the future. That it's important to have an efficient technology to recycle, for example. That's, I think, one key asset. And we are convinced that and also to have the capacity and to deploy the technology in Europe. That's important. So we need to invest in R&D, in innovation action, but also in a new plant in order to have the capacity to recycle of these batteries that will come in the future.
Well, for Umicore, like for us, it's, again, the battery recycling is one of the key. But also I'd like to mention, let's say today we have several discussions on new batteries like LFP or sodium-based and solid-state batteries as well. But new battery means new challenge in the battery recycling because it's going to be totally different chemistry we have to recycle for. And sometimes, now it's personal feeling, but I feel quite annoyed, to be honest. Well, I mean, there's so many like new batteries, so we have to be really flexible towards those new feeds. So then those kind of like R&D investments should be done for the battery recycling to expand our process window to the new batteries.
Yeah, so I totally agree with what my colleague said. Let me step back a second. I mean, here we are talking about closed-loop recycling of battery materials. So the reuse of these materials at the same or similar quality levels of the raw materials and in specification. So this is extremely challenging. And even if you think about very established recycling chains for other type of products, I mean, many times these are a mix of closed-loop and open-loop recycling where you reuse the materials in other applications. So we have seen the numbers in the previous presentation of current rates quite low for some fractions at least. So I think that we are really putting a lot of a very big challenge on the recycling industry and on the technology providers themselves. But in Europe, there is a huge competence on production of smart, advanced, digitally enhanced technologies, both in production and in recycling. So I think that probably as a community, we should also be more effective in transferring these requirements to this industry, trying to get them more closer to the problem and try to exploit, for example, robotics, automation, smart manufacturing techniques in order to increase the quality of the streams that we gather out of recycling process chains. It's challenging, but it's doable. There are competencies around in Europe.
None of you mentioned dismantling of the batteries. You were directly jumping to the more chemical part of for closing the loop. But what about these issues on collection and dismantling of the end-of-life batteries? Is it something that you feel will be easy to do, or that they are also bringing their part of challenges?
Well, as a researcher in this field, I saw like tons of batteries and hundreds of different type of batteries, pack, module, and cell. And sometimes, like even in the same pack, looks exactly the same, but inside is totally different. Or module exactly looking same, but inside is totally different mechanism there. Or like the position of the screw is different. Like those kind of like small change was always made in the battery manufacturer. And I think that's a good thing to evolve a battery manufacturing method. But on the other hand, for recycling, indeed, dismantling is one of the key to make sure we can make batteries to the, good enough, like small size, so that we can process in the hydro step or pyro step for further refining. That could be the crucial, but still, because battery industry is evolving, also battery technology is developing, that makes the situation much more complicated.
I can tell you our experience. So I work in the mechanical engineering department, and we have been developing 5 years ago a pilot plant for disassembly modules into cell, and of course testing and diversifying the reusable cell from the recyclable, the cells to be recycled. And we also developed this technology for automatic cutting of the cell case in order to increase the quality of the materials. We started from the background of the technological background of robotics, of cutting, machining, and the problem is not easy at all. I mean, the variability that we encounter in battery, even at cell level, of course, at cell level, it's reduced a bit with respect to the pack level, but still, it's probably wider than any other production case that you may even think of in the linear, let's say, process chain. So it's challenging. Of course, the combination of solutions is reducing a bit the variability of the input material and at the same time making the process more flexible. The combination of the two may find sort of a compromise or trade-off point in a sort of economically viable way. The issue is scale up. So at the moment we are okay with the process setup, but when it comes to scaling up to 10,000 tons of batteries to be treated, there is the big challenge at the moment.
Scaling up, and what about, are these processes also flexible enough really to deal with different types of batteries, and so that you don't have to develop specific parallel lines for the different types of batteries?
Yeah, well, in my view, flexibility is always focused. So there's no infinite flexibility. In production, this is impossible. So at some point, you always have to cluster and to dedicate the capabilities of your technology to a subset of battery chemistries and geometries, and then replicate few ideas in parallel lines for different geometries of electrochemistry. But of course, the level of flexibility that you can give is a matter of research and type of technology you select. So it's a lot of projects ongoing in Europe. So I'm sure that in the next years we will find very interesting solutions there.
What is your opinion on this concept of sustainability by design or recyclability by design, so that really we, from the beginning, from the conception of the design of the battery, we already anticipate the dismantling and recycling phases. Where are we from, let's say, a technological point of view, and what is the maturity of this approach, and what is the potential you see for these approaches?
I'm not sure that there are some manufacturers, some battery manufacturer have in mind the dismantling, because when you see for example the Tesla battery, it's very complicated to dismantle this battery. So I expect that the next generation will take into account the design. But up to now, what we saw, it's so you have to dismantle first the pack to a module. So at this stage, it could be even with that, with the same model as it said. He said the module, the arrangement of the module is very different. So I think that effectively, so the design, has not the recycling phase has not been taken into account at the beginning. So that's why the recycler need to develop a system that could be versatile in order to be able to take all type of packs and modules.
Well, as you mentioned, like it's quite well. It's in reality, like it's actually we are seeing more and more different types of batteries, more on the variety of batteries in reality. Well, as a dream or like as for the future, we should make sure like the battery manufacturer will make a battery or will design their battery pack easy to be dismantled. But then in reality these days, there's more and more batteries coming with different shape. So then, well, so I would say this is transition period. Like after 2030, maybe there's a new approach for the battery design, but meaning we can only receive those batteries after 2040. So there's always 10 years gap or 15 years gap even after the production of the battery. So what Umicore is trying to do is more like to minimize the dismantling. Let's say if you have to dismantle battery module to the cell or cell to black mass, it's always complicated. So we make a process which we can we can feed battery module scale or even the pack scale if it's going to be small to the smelter, then we can extract nickel and cobalt to minimize those risks. That's our approach so far.
Well, if I can, I think that the design for sustainability or for multiple use cycles or for recycling, whatever we want to call it, it's definitely a great idea. Something can be made, of course. Some type of joinings can be avoided, for example. Some position of the joints can be made more regular. The point is that we always have to consider that the reason why these packs are designed in this way is to fulfill the first life cycle, right? The requirements coming from the integration in the car. So, of course, again, something can be made, but we have to consider that if we put more constraints in the design process, then the design process will end up with less and less feasibility set in terms of solutions and then higher costs during the design process itself. So there's always a trade-off between the two things.
Another concept which is very much supported by BID2022+, I think Christina is in the room, but about this direct recycling concept, so trying to not to go back to the elemental stage of the metals, but trying to recover some active components in a not too degraded way, so that we avoid to go in the big loop, but we have a shorter loop. What are your expectations and opinion on this approach? Where is this technology? I know there are also a lot of research in the States on this in that field.
So I think that you speak about the direct recycling. So it's to regenerate directly so the cathode material. So effectively something that so we are investigating this way because it's interesting. You reduce effectively the work to in order to have the material. There are some challenges because the direct recycling could be very efficient for scrap production, because it's not used material. But after used material will be more complicated because there are some impurity. The material has been changed during the use, so it would be difficult to recover exactly the material. But so there are a lot of work on this area, and so. Or also work on this area, and so we have some interesting results, and so it's a way also to reduce the cost of the recycling.
Yeah,
so it's also interesting.
Environmental footprint and the consumption of energy and so on. Yeah, indeed. There is one topic that we have not yet touched at all, which is the battery passport. How this new initiative could also contribute to achieving the targets of the level of recycling that are now in the draft regulation of the battery directive.
Battery passport is really helpful for the battery recyclers, especially again. As I addressed, there's batteries which looks exactly the same, but inside is different. So we cannot judge inside the battery just from the appearance. So if we have battery passport, we can already identify the origin of the battery and could be the composition of the battery. So that could be really helpful. But then one thing I think battery passport still should include is the deregistration. So last owner of the battery should be free. Should be able to give their ownership to the recycler, so that recycler can recycle without any registration program. That should be included. But in general, battery passport is quite helpful.
Yeah, in my view, very interesting concept. Of course, implementation is under discussion from the technical and from the value chain-oriented point of view. I think that we should also think about what information to transfer to whom along the value chain. Because it's not true that all the information about the batteries are useful at all the stage of the value chain. If I'm a disassembler, a dismantler, I probably don't need to know the details of the chemistry of the battery cells, but I need to know very well the position of the joints and the type of welding technology that has been used. So, trying to cluster a bit the type of information that is transferred along the value chain can even decrease a little bit of resistance of the value chain to this concept. Just for, to share this information, there is a new project that is going to be started next month. It's a CSA, it's called CircPass, exactly on the digital product passport principle. It will last 18 months, so very, very short-term effort. And battery is one of the pilots of this CSA. So let's see what will come up out of this activity. It comes from the digital world, but I'm sure there will be interesting results that we can further discuss in next steps. We are involved as a partner in this project. It's led by CEA in France.
Okay. Before we move to the questions from the audience and also from those who are following us remotely, I have a last topic I wanted to ask for your opinion. Very frequently, and I'm sure this will be part of this Raw Material Act, there is a lot of expectations on substitution. So substituting the critical raw materials by less critical or not critical at all raw materials. Sometimes I have the feeling that it's misunderstood and it's more dreaming of a magic drop-in solution, while it's probably also the best way to address it in my view, but I really would like to have your contribution on that, is to broaden the panel of solution and really the range of technologies so that really we are reducing the pressure and really reducing also the dependency on some specific technology. So what is your thoughts on that?
We've experienced that challenge here in Brussels, talking to certain politicians or members of the European Parliament, and their answer to this challenge is often we'll just recycle more and substitute things, like you say. And to get the accepted, that's why we try and present this bridge to try and show actually it's a number of interlinked options and you can't take one out. And substitution happens where it can, and industries, companies work very hard to improve their efficiencies, but there are limits, and the real peak in demand we see for these materials is around 2035, and that's not so long away. So we try and provide realism into the debate. I think it's getting there. The fundamental priority is to get materials into the system to the lowest impact possible and using the least we can based on what we've got available, and then to keep them in that closed loop. But yeah, so it's certainly a challenging one. And recycling, unfortunately, is even more pervasive. And I see sometimes the biggest battery recyclers are actually having to come and defend the need for new mines because we also need the full supply chain to operate. So I think that's a collective job to improve, but interested in others.
Any comment on this substitution aspect?
Well, I can only address again for the importance of let's say especially about the recycling content of European battery regulation already have recycling content should be like 4% of lithium by 2030. Those kind of targets would be quite crucial, and that can really motivate us. But at the same time, we have to make sure when we talk about recycling, we really specifically talk about specific elements. Like recycling is a big word, and sometimes people are saying only the recovery of nickel, but it's not enough. We have to make sure we can recover nickel, cobalt, lithium, everything, all those important elements in battery to make sure we can have those battery materials stay in Europe. That's the importance I like to address again.
just a small further comment here. You mentioned before direct recycling and the capability, possibility of further improve this technology, this solution that seems to be promising because of costs. And I totally agree. Then, of course, this will be somehow combined also to this evolution and the substitution of key materials in batteries in the future. I just wanted to add that in any case, direct recycling needs to be scaled up and is under scale up. And you need some pre-treatments in order to be able to apply direct recycling approaches. So probably will not completely, let's say, eliminate the need of some automation, some pre-treatment, some, pre-sorting of the material, of the components for enabling direct recycling. But very interesting stream.
Okay, thank you. So I would like now maybe to move to questions. I don't know if there are some burning questions in the audience here, so please raise your hand. And yeah, if you can quickly introduce yourself.
Yeah, absolutely. Hi, everyone. My name is Migla Bluseviciuta. I'm from BASF. And I think Chris already knows what I'm going to say. Actually, Chris already made this point, and I think the other panelists as well. I just really think we should reiterate this. So we want to circularize the battery value chain. We all agree that there's tons of challenges for raw materials, and we even more so agree that recycling will hopefully solve or basically provide part of the solution. Now, I think it's been said several times on this panel that valuable battery recycling resources, especially the black mass, but also cell and module waste, should not leave Europe. And today, I mean, this is a currently permissible scenario, and it does happen. I mean, as EU recyclers, we need to prevent this from happening. And it sounds all high level and important, but when we start talking about the real solutions, it becomes really tricky. And there's a lot of technicalities there, a lot of sensitivities, and a lot of different interests among different players. And probably my question would be best addressed to a policymaker of the EU. That's not the case today, but I think that our esteemed panelists could try to provide some answers. And my question is basically, how do we do this? You all agreed that we have to do this. I mean, sure, I have ideas of my own. I will not really go into details because they're quite technical, but if we can stay on high level, what would you suggest, for instance, to you policymakers, how to prevent these valuable battery recycling resources from leaving European Union and going to somewhere abroad where, I mean, they're recycled under laxer environmental and in general HS standards, and in the end, they're then shipped back to Europe at a tremendous CO2 impact, and they enter European market in foreign batteries and creates huge disadvantage for EU recyclers, but not only the recyclers, but for the whole EU battery value chain.
Thank you very much for that very valid question. Indeed, that's something that I also came up to my mind while you were setting up the scene. So I don't know who wants to take it. Please, not everyone at the same time.
No easy answers. I mentioned it in my presentation. I can echo the problem, and I guess a message to policymakers would also be not to be naive in this situation, because sometimes there's an assumption that as Europe, we're good at recycling, and so we will be good at battery recycling when it becomes available, and that will be easy. But the reality will be it's going to be a very competitive global market to access this scrap. Currently, China, even South Korea have bigger scrap pools available to them because they have bigger markets, so they're more easily able to build up this capacity and have the input feeds to do that. Some strong industrial strategies, again, I think South Korea have a really strong strategy. They even will pay their companies subsidies to get materials from abroad to give them an advantage for this scrap. So firstly, let's not be naive that it will just be easy for us to do this and then make the rules. We shouldn't be protectionist or take that approach, but make the rules clear there so it's hard to recycle some of the intermediary inputs like black mass abroad before they've completed the recycling chain. Whatever metal we're talking about, we always advocate that we measure recycling at the end of the process. So what material is made available that can substitute primary material. I think if we have that clear picture for batteries too, that will avoid us making it too easy for things like black mass to escape early. And there are some very technical points which Migle also touched upon to do with if you call it a product or a waste and how easy that is to ship. But in general, we shouldn't be making it easy to ship black mass just for the sake of it. We should do what we can to keep that supply chain with the rules.
If I can be optimistic, I see the ecosystem is moving. I mean, the problem is challenging, we said that. It's challenging even for other product fields. Batteries are even more challenging for certain aspects, right? And the ecosystem is moving. We see technologies, new ideas, new strategies being implemented, tested, and tried to be scaled up in the last years very quickly. What we can do is probably keeping all stakeholders together and keeping all stakeholders working in the same direction, of course respecting different roles, and involving some competencies that are very good in Europe, like, as I said, automation, robotics, production technologies, recycling technologies, and try to transfer to these industrial partners the requirements that we need for overcoming the challenge.
Mm. Yes, please.
Just, you remember, the other fundamental part is indeed expecting the same standards from our partners as we would expect here in Europe, which the EU tries to do with its waste shipments regulation. And that's very difficult to do on a global level, to have equivalence between standards without being protectionist. But clearly that's an area we need to go to give the level playing field.
Now, I know that we don't like protectionism of the world in Europe, but I think that indeed we have to avoid being naive, and we need to find a way that really the standards level that we will be imposing to our industries will be really fully valid for whatever the source of the battery. There is a question that came already from the remote audience quite a few minutes ago. That was really also echoing a point that you mentioned in your presentation, Chris, that Chinese companies are expanding on ownership of mines for key metals. And the question is it possible to predict what the impact would be on European industry dependent on these key metals if China continues and maintains its expansion in this market? I think that was really the main topic of the day, but it's really more geopolitical, how to more or less find a way not to continue just looking at what Chinese are doing, and how to, on our side, also develop this strategic partnership with key partner countries like Australia or South America or others, and not to be in 5 years or 10 years from now with nothing anymore in our hands. So, are you aware of some political, more geostrategical initiative that really are addressing this issue that I think everybody knows for a while already? But
I can answer again, but if others, it seems a China bash today. I think problem we have is that we don't have a global strategy really for raw materials. China has had for 10 to 15 years. Europe has not really looked at how it could invest into resources around the globe. It tries to make progress now in terms of partnerships with other regions, and the easier thing to do is partnerships with like-minded regions. It's easy to talk about a partnership with Canada or Australia indeed, because the same standards are there, etc., which will secure some supply but likely not enough. More challenging will be the more risky jurisdictions where it's much harder to do business in the sustainable way that we want to. Thinking of Africa, Indonesia, for example, where China's also dominating, and there's a lot of ESG concerns. So I think having a strategy for accessing some of these very competitive resources and using things like the EU has a global gateway fund for developing infrastructure across the globe, like the China's Belt and Road policy, directing that more towards raw materials projects and trying to find a model for delivering not just a mine, for example, but also benefits to the communities is probably the way forward. There's maybe a small window of opportunity because anecdotally we hear that the experience communities have with operating next to Chinese operations and the standards, the low employment levels, the missed promises is meaning that they are looking now for other options. A question whether Europe is brave and fast enough to take that, and it's a very tricky area to do. Otherwise, the risk of the question is clear. We don't know the risks, but having a geopolitical control of key strategic materials can be very problematic.
Yeah, obviously. Questions? Oh, a lot of questions.
Okay, good afternoon all. My name is Luigi Crema, Director of the Center for Sustainable Energy at Fondazione Bruno Kessler in Italy. There will be a competing demand not only in between Europe and the other countries, but even inside Europe on critical raw materials in between the different sectors because of the increase of this demand. You have mentioned that on tomorrow the President of the Commission will make a statement on this, and the European Commission, of course, is trying to collect all of this information and having a top-down approach. But do you consider useful to establish a bottom-up approach to collaborating between different sectors, to find joint solutions or collaborations in trying to establish even a common strategy on critical raw materials in Europe, for example, in between the different partnership, the Clean Hydrogen JU, with the BEPA, with the Clean Energy Transition Partnership?
Well, it's a very good point, and thanks for the question. I think that the cross-sector nature of the problem, speaking about materials, is clearly an important axis of analysis here. And this kind of cooperation or discussion can be definitely activated at local level, where there is some knowledge of stakeholders in a specific sector. Should be activated also at a more strategic level, but I think it's more complex because our cross-sectorial links in Europe and in different member states is not super established yet, right? So we see this in other fields of circular economy, where even connecting sector that can be potential reuser of materials for coming from scraps or waste in another sector is difficult. So imagining this complex ecosystem that we are aiming to create. But it's a very interesting framework and interesting point of view on the problem, I think.
Chris, maybe you want to react also on this one? Or?
Yeah, I agree there's potential. It's also hard when access to raw materials is a competitive advantage too, to have such close collaboration, I guess. There's a lot of just working to secure a supply chain per company at the moment, and specifically the pool of responsibly sourced sustainable minerals is even smaller still. So I think there's room for more cooperation, but it remains competitive environment. I know the European Commission is exploring options, for example, for stockpiling at national level of certain critical minerals that would allow it to react in terms of crises. This is, again, difficult to coordinate between member states, and as an industry, we would say it's of a lower priority to some of the other topics. But yeah, discussion's ongoing.
Yeah.
Hello, I'm Leopold from ETH Zurich, and I have a question regarding the greenhouse gas emissions occurring along the value chain or supply chain of batteries. So I think it's pretty clear that in the upstream part of the supply chain, we do see tremendous energy involvements, both in terms of electricity, but also in terms of heat. And so part of my first question is essentially, do you see a competitive advantage if Europe vertically integrates the battery value chain in terms of a carbon footprint? And the second question is, how can you steward the carbon footprint when comparing the value chain, say if it goes from Australia via China to Europe versus locally sourced or even just locally refined battery materials? Thank you.
Okay. for recycling, for secondary material, so issue from the recycling, so the carbon footprint is lower than from the primary material. So it's important, and so it's valuable for the recycling. So in terms of gas emission, of course, depending also of the type of recycling. And so there are several types of technology to recycle, and some are more CO2 gas emission intensive compared to others. But globally, the recycling, to recycle material, provide less GHG emission. That's the first one. The second question was.
Yeah, the second question was essentially.
Okay, so the advantage for Europe compared to China, for example, effectively depend of the production of electricity. So today, Europe has the carbon footprint emission for electricity is lower compared to China. So it's an asset that we need to valorize and to take into account when we if we want to have a sustainable system. And so it will be important also to take into account this element when we speak about the battery passport, to indicate also all the emission during the manufacturing as a different step of the production, as the use of the material. So it's very important, and yes.
Maybe one addition, there's, of course, greenhouse gas emissions different based on the different technologies of recycling, but also it differs from the materials or from the elements. Let's say we had some life cycle assessment internally in Umicore, and we found out, let's say, like having nickel and cobalt recycled in the system, it really helps us to reduce supply chain greenhouse gas emission. But it's not the case in manganese. So manganese, the production of manganese and recycling of manganese is more or less compatible. So then I just like to highlight, it really depends on the elements as well.
Thank you. I will take maybe another question from online, and then coming back to the audience here. So there was a question from Thomas Lewis asking, what's your opinion about the minimum recycled content targets for the new batteries that are under discussion in the battery directive? Do you think the draft values are feasible, I guess achievable?
I think it's feasible, but it's also going to be helpful if we can, if this European battery regulation can take into account on this production scrap as well. Because right now, the current regulation is more for the end-of-life batteries, but then some production scrap is also contaminated, so we need to recycle back. Then if we can take these numbers into account, it's much more realistic, I would say.
Okay. Someone else yet? Please. Wait for the mic. Yeah, thank you.
Hello, my name is Oğuz Çolak from Eskişehir Technical University. When we talk about the battery passport, I think we need to define the life cycle assessment of the passports digitally inside this passport. Is there any regulation about how can we create the life cycle assessment inside the battery passport? Or the way, how can we define these parameters?
I can try and answer, but I might be wrong. I think there is a methodology at EU level called the Product Environmental Footprint, which aims at comparing LCA results across processes, products, etc. And to my knowledge, the Product Environmental Footprint is being utilized as a basis. Also, the Battery Association Recharge is working on it in much more detail than me, so I'm only from the outside.
And I think I can add that there is also an ongoing project, a CSA, that has been launched jointly between the 2.0 partnership and BAT4EU partnership, really specifically to address these issues, to build the more robust methodology, really to not only to develop the appropriate LCA, but also about the inventory of data, how to really get the most reliable and meaningful data, really to feed this LCA. Yeah.
Can I just highlight one thing that it was contained in the question and in your answer as well? It's very interesting to see the services that can be attached to the concept of product passport. We are talking about LCA services, so analysis, but there might be many more services that the IT, the digital technology world can be thinking about in order to improve the efficiency of the processes themselves. So I think this could be a very interesting perspective for the future of this technology, of this solution.
Absolutely, yeah. How to transform a constraint into an opportunity and to really to provide added value about from all the
exactly.
Yeah, exactly. Yeah. Okay, I think we still have time for a couple of few questions, so don't hesitate, don't be shy, please.
Hello, Tuğrul Çetinkaya from Sakarya University in Turkey. So my question is about actually that I will have a very direct question. So should we expect this same capacity and energy density behavior from the recycled battery? I mean that there should be like any regulation for this. And quickly the second question, when we get a battery module for recycling, you know that there are some cells which can be used for a second. Secondly, and some of them we should send it for the recycling. So, is there any regulation for that as well?
Managing the state of health at the end of life and how to sort them.
Yes, and, what parameter we should take into account.
Yeah. Well, maybe from the second use of the battery, there's more and more topics on this. Like second use of the battery, but what we heard from our partners or like our business counterparts are, let's say, for battery manufacturers or OEMs, we still don't know who. Well, even after you give ownership of your battery to other people, well, there's some like ethical responsibility. Some OEMs or like battery manufacturers should care. Then for the second use, you cannot really guarantee how those batteries are going to be safely used. So that's going to be the biggest challenge for battery manufacturer. And for the second question would be like, well, again, it's going to be 10 years after we receive batteries. Then maybe we can check some batteries, and if the battery status is okay, they can be reused as secondary batteries. But then we can also recycle battery to make new batteries, and in 10 years, looking at current development of the batteries, it's going to be huge development as well. So the question would be whether we should discard our option to recycle battery to make new, more advanced battery, or we choose for the second reuse. That could be the discussion point.
Okay, I think there was a question from this side. No, not anymore? Yeah.
Hello, Dari Hedberg from Geyser Batteries. We have been seeing that we've been kind of trying to catch up with the battery technology development, with the raw materials, and competing against Asia continuously. I know it's, of course, early to talk about, 10, 15 years from now when we have more and more new technologies, battery technologies coming onto the marketplace. But still, how do you foresee what kind of framework we should imagine and develop within the European Union to ensure that we don't end up in the same situation as we are now with the lithium-ion battery materials with the new emerging technologies in the future, so that we don't have to, again, try this catch-up game play? Yeah.
There's there's certainly a risk now that we could pay just attention to the materials we need today, and then indeed in the future we face further pitfalls for materials we weren't aware of. And that's difficult. I think early monitoring from the European level about what's incoming and early intelligence about where technologies might develop so we can identify critical materials in advance. Currently, our definition of critical raw materials only looks at today, the present day, and backwards. So better foresight is for sure part of the equation. And looking at the new technologies, I guess getting there for things like lithium, which will be needed now, will be needed in the future. So even when there's a new technology developed, we've got the infrastructure here and we're equipped to build on it quickly rather than giving up the battle now and then being further behind when the new generation comes.
Yeah, I think this is a very important point that we should also really start tackling now. Also because we cannot claim, we cannot ask the recyclers to reconvert the lines every 5 years, right, or 10 years. So we should probably share more information about the emerging technologies and start thinking about flexible systems that can be somehow reconfigured with lower costs to be ready to accommodate these new products that are emerging and will be definitely upscaled in the future. So it's a very good challenge and point for the next strategies of innovation.
And another interesting question online, again from Thomas. So, very prolific one. Some of the cars currently sold in Europe will be sold abroad, exported to Morocco, Kazakhstan, for example. Do you expect those cars to be shipped with their batteries? And so, at the end of the question is also how to take care of, or to take into account these exportations in the figures, so that needs to be achieved on the with the battery directive.
I think it's not only for the cars that could be sold abroad, that the question is a general question for how we collect all the end-of-life batteries after 10 years, and so the car maker have no idea where are located these batteries. So I think that a new framework need to be developed in order to localize the battery, and so to collect this battery in order to be recycled or to be reused. And I think it's one important logistic action that need to be developed. Yes.
I know a third of the cars today in Europe are unaccounted for. We don't know what happens to them at the end of life. So that's already a big loss of scrap value for the aluminium, the steel inside those cars. They leave Europe, some of them illegally, and it's a material loss. The figures in our recycling figures in the study are assuming that every car is reaching the recycler here in Europe, and that's a huge bottleneck that has to be overcome. To be seen if there's a difference with the electric vehicles, they need infrastructure, whether they travel as far and as easily. But yeah, that's a big problem now and in the future.
Yeah, just an illustration. I think that the devil is always in the details, and that's typically the kind of thing that will need also to be addressed in a way or another. One last question, please. Yeah.
My name's Gerhard from Fraunhofer. I have an easy question, probably. I'm wondering if the R&D landscape and the European projects, etc., if they consider enough to work with the recycled materials. Because, well, I think there are some impurities which make some special problems and challenges. Is that something which is not, which is addressed enough? Or should there be even a kind of incentive that R&D projects oblige themselves to work with recycled materials in order to foster these developments?
If we want to close the loop, so we need to have an efficient recycling process, and so in order to achieve high purity products, And so it's important, because if we have not the high quality, we could not remanufacture new cathode material and new batteries.
So that means that possibly we need still additional efforts on R&I actions really to make sure that we keep the level, the quality level that will be needed to.
I think that during the production, all production activity need to improve their activity, and so we develop solutions that achieve the target of our customer. But if we have a relevant and new innovative system, so we'll implement in our production. So the R&D effort will be necessary during all the operation of a plant. In any case.
Archie?
Yeah, I mean, like there's always possibility of some more contamination from battery recycling comparing to the manufacturing the salt from the primary resources. So I just like to address the importance of having feedback from the battery manufacturer, especially cathode manufacturer, on whether they are okay for the contamination. Like Umicore is one of the cathode manufacturer, so we have in a way very strict rules on the contamination level and also composition level. So those kind of feedback could be the crucial for the battery recycling.
Yeah, and I think it's even more than feedback. I see what we are seeing in the industry are really strategic partnerships between materials producer, OEMs, car manufacturers, and recyclers, really to build and to secure this loop.
Indeed. Also, that can be different. Let's say like which kind of process you take, or even how you dismantle the battery, that can really change the concentration of contamination too. So those strategic partnership on the whole supply chain of the secondary resources of the battery could be quite crucial.
Maybe your last very two sentences concluding remark, what you want really the audience to keep from this discussion. Marcelo first.
Well, I will just follow up on what you said. I mean, we are really looking forward to realize a closed loop recycling process chain, and a lot of issues are emerging. This propagation of requirements specification is one of the key issues, and in my view, the other is the adaptability of the technologies that we propose for the recycling process chain. So hopefully in the next year we will advance in these innovation areas.
I think for Europe, so the innovation, it will be important, and so we need to develop greener recycling process with very low emission, CO2 emission, and so it's important, and it will be the opportunity for Europe to be ahead and to be proof that we could achieve that.
Chris, the last word for you. Oh, sorry.
I've already mentioned. There's an importance on more efficient battery recycling process, and also like good regulation system as well to motivate more for the battery recycling.
Let's all just be clear on this full supply chain that we need primary metals into the system urgently for our energy transition to go forwards. We need those recycling loops, and we need to not be naive that they happen automatically, and there are many bottlenecks we've spoken about at each stage, which hopefully collectively we can overcome in the years ahead.
Yeah. I think that will be the last word, and that was also my conclusion, that I think that this challenge can be addressed only if we address it collectively between the different segments of the value chain. So it's also a great topic to be really supported by the partnership and by the different initiatives which are supporting the battery value chain in Europe, because I think that each individual stakeholder alone will not be able to address it, that's really a collective effort. Thanks a lot to all of you. Thanks a lot for the audience for your very attentive attention and also for all your very interesting questions. And we look forward for seeing you in the next sessions, and still tomorrow for a very interesting second day of this Battery Innovation Day. So thank you very much. Yeah, and so the next session here in this room will be the accelerating research to enable the batteries of the future.